Afternoon, students. Good afternoon. Can you hear me? Can you see the screen?
Yes, sir.
Hello? All right, good. So we're recording the session. No number of person not here. So we're recording it. So we're gonna start anyway. So persons who are not here, they can always, get the video. So I did send these two. Did send two papers for you guys to do some questions on for revision. Um, we'll start back our regular classes. I think I start back on Tuesday. I'll let you know if we have a class on Sunday for pyramids. I'll let you know by tomorrow. I don't want to do any online class. We are teaching anything new, so I prefer to wait until we can actually go face to face. I don't know that we'll be ready for face to face on Sunday. All right, so maybe we start Tuesday. The thing is that next week Sunday I have a funeral, so I won't be able to keep face to face class next week Sunday. So I'll work it out. All right, I'll work it out. Might actually do something Sunday then, this Sunday, because I can't keep class next week Sunday. But I'll let you know. All right. And let's work through the questions on this paper. Hopefully you did them, and it's now just a matter of from your mistakes. Right. And let's double check what I'm going to explain with what you did. All right. So I think I gave you 3 questions on this paper. This is the first. No, you're not supposed to do 1A because that's functions. Function no longer on the ADMAT syllabus. It's on pyramids, but not on ADMAT anymore. But I gave you this one. All right. So this one says we have to derive the polynomial of degree 3, meaning highest power is x cubed. All right. In which the roots are these. Remember, if you know the roots, then you automatically know the factors. Alright? If you know the roots, you automatically know the factors. So roots are x equals 1, x equals 2, x equals negative 4. It means that p of x, when it is factorized, not f of x, p of x, factors will be x minus 1 from this root, x minus 2 from this root, and x plus 4 from this root. And I want us to expand it and write it in descending powers, right? But they didn't say that still, but they say of degree 3. But this is basically the function, but we have to do something with it. So I'm going to expand it out. So I'm going to multiply these two first. So let's put x minus 1 times this times this is x squared. And the middle term is the far product and the near product. The far product is 4x, the near product is minus 2x. So the middle term is 2x plus 2x. And then the last term is negative 2 times this 4 is negative 8. Then now, to expand this, I'm going to use these two and multiply those 3 values. Using the x first, this times this times that, that times that. So it's going to be x times x squared is x cubed, and x times 2x is plus 2x squared, and x times the 8 is minus 8x. Then I used to use then I need to use a negative 1 now. So negative 1 times x squared is negative x squared. Negative 1 times 2x is negative 2x. And negative 1 times this negative 8 is positive 8. Then we consolidate the values. That's the only cube term there. That's x cubed. The squared terms are this one and this one. That's 2x squared minus x squared. That's 1x squared, or just x squared. And the terms in x is this one, those two. Minus 8x and minus 2x give negative 10x. And then this is the only constant, plus 8. And that is the answer right there. That's P of x as a polynomial of order 3. Are you good with that? Right, okay? Hello?
Sure.
Alright. The next part gives us this relationship. V and T are related by this. And it says use logs to derive the equation in a form y equals mx plus c that can be used to find the value of k and a. So we need to write this in a linear form. Alright, so we have to take logs to get it out, and it tells you here use logs. So we have v equals k a to the t. I'm going to take logs of both sides. So I'm going to log the left side and log the right side. When you take the log of this product, it becomes the sum of the logs. So it becomes the log of v equals the log of k plus the log of a to the power t. And this t can come to the front, and that's a variable, right? T is a variable, just like the v is a variable. So it stays as log v equals, I want to do this term first, put this term first because I want it to look like this, mx plus c, put a t in front. So this term will become t log of a. The log of a is a constant. Because I want it to look like this, I'm going to write it as log of a times t. Alright, that's what I'm going to put right here for that. So that's log of a times t, and then this is a constant, log of k. So plus the log of k. And basically that's it. And this now is in the form y equals mx plus c. So this is your c, this is your m, and this is your vertical axis, that's your horizontal axis. Question says, if a graph, don't you know, if a graph of y versus x, this is your y now, log v, and this is your x and the t, right? From the equation in part 1c is plotted, a straight line is obtained. State an expression for the gradient. Expression for the gradient is the log of a. So the gradient would be m equals the log of a. That's the expression for the gradient. If you wanted the y-intercept, let's put it in a bracket. If you wanted the y-intercept, then that would be c equals log of k. It would be c and it would be equal to the log of k if they wanted the y-intercept. So the expression for the gradient is this, and the y-intercept is that. Are you okay with that?
Yes, sir.
Alright, good. That finishes that question, number 1. Then I told you the number 2 is part of it. Now give us this thing. Notice a frown shape because the square term is negative. This is g of x, and I want us to write it in this form. Complete the square. So remember, we always want to get x squared plus nx to complete the square. That will become x plus n over 2 squared minus n over 2 squared like that, right? So we want to generate this x plus nx. So out of this, I'm going to factorize away the negative sign, or the negative 1. So my g of x first is going to become negative 1 into, this becomes x squared, this becomes minus x, and then subtract back this 3. You're completing the square up inside here now. So it becomes minus 1 into, When you complete the square of this now, you're gonna get x minus half of the number here. Number here is a 1, half of it. So get 1 over 2 squared minus the square of this, which is 1 over 4 or 1 over 2 squared, if you like. And then you subtract back this 3. So what they really do is a 1 in front this, that will half it to get the half down here. Then we subtract the square of that. That's how we complete the square. And then now to simplify this now, it becomes equal to minus 1, that's like a into x minus half squared. That's minus 1 times this first, right? Then minus 1 times this becomes plus a quarter, because 1 over 2 squared is a quarter. So we get plus 1 over 4. And you're subtracting this 12. Now this 3, this 3 is same as 12 over 4. Why am I putting over 4? Because this one is a fraction with 4 in the denominator. So I'm going to put that as 12 over 4, this thing, minus 12 over 4. Because 12 over 4 is still 3. And then to simplify, let me make this a little smaller and zoom in. Alright, so this then becomes equal to minus 1 into x minus half squared. And this and this becomes minus 11 over 4. And that is it. That's g of x after complete the square. Then down here says now, on the grid provided below, sketch a graph. So give us this grid to sketch a graph, right? But that's some of the key features. First, it's going to have a front shape. And the maximum value is negative, that's correct, minus, yes, that's what it is. It's just going to be entirely below the x-axis, and like here. Alright. Going to be below the x-axis. Because this is a maximum. It's a maximum and that's a maximum value. So the maximum value occurs when this equals 0. And that equals 0. When that equals 0, the x equals half. So the maximum point, put it down here. The maximum point is going to be half minus 11 over 4. The 11 over 4 is 2 and 3 quarters. 2 and 3 quarters, right? That's 11 over 4. 2 and 3 quarters. Then you're going to cross the y-axis at negative 3 constant there. So the y-intercept is 0, negative 3. Alright, so it's going to go like this. So give us some grid. Give us a grid. So we're looking for half minus 2 and 3 quarters. So this is where half. That's a half. Put it on the not minus a half, plus a half I want, sorry, plus a half, not minus half. So right here will be a half, and minus 2 and 3 quarters. Now right here is 2 and a half. 2 and 3 quarters about here. So you know that it turns up here, so that's the turning point. That's the maximum point. This is the maximum point right here. Right? 2 and 3 quarters. Remember, let me make it more accurate. Let's look. This is minus 2 and a half. And then you go about here for minus 2 and 3 quarters, and that is half. So that maximum point is right here. The thing about it that it crosses y-axis at minus 3. So it passed through the origin. It passed the y-axis right here. Minus 3. So it must pass over here by the same amount. So it's gonna basically go like this. I mean, we need to do it a little bit more accurate because they give us some values, right? So let's just get some values on it. Is it the same function that we did up at the top? No. So because they put a graph paper, guys, it says on the grid provided, it says a sketch, but you know it's a sketch. Because I put on a grid, I want to work with a couple of values with it. So I know that that's the maximum right here. and it's gonna pass through 0 minus 3. But because the graph is symmetrical about this axis of symmetry, you're gonna pass through this point as well. I'm sure if you put 1 in the function, you're gonna get -3. Let's show. Put 1 in this function right now. X equals 1 in this. Put x equals 1. You're gonna get g of 1 equals -1 squared plus 1 minus 3. Right? Now this is 1 squared is still 1. This becomes -1 plus 1, which is 0. 0 minus 3, this works to be -3. Alright, so everybody can see that. So it's going to become -3. That's why I have the point 1, -3. Right here. Here, 1, -3. Let's put in 2. I think 2 is gonna be way down, because this graph like it's gonna go something like some go down like this. But let's see where 2 is. Alright, where 2 is. So x equals 2. We do g of 2. That's gonna be -2 squared right here plus x, which is 2, and minus this 3. So this becomes -4, and this becomes -1. That becomes -5. So this all works out to be -5. So 2, -5, all the way down here. But again, the graph is symmetrical about this axis of symmetry. So you see whatever this distance is, so the same distance go down to -5 on the left side. That's 1, 2, 3 units, 1, 2, 3 units right here. So I'm sure that -1 is also going to give a -5. But let's show it. Right? So those are some points on the graph. But let me calculate it for you and prove that it is true. So those are some points on the graph right now. So I'm saying -1 is also going to give a -5. Let's prove it. Right? So I put x equals -1 on this function. Then g of -1 is going to be negative -1 squared. And then this plus x become -1 minus 3 equals. So this works out to be a 1. So it's -1, -1, and -3. That all become -5. That proves it. -1, x give you a y value of -5. So those are some points on the graph. You can sketch it through, sketch the graph through those points now. Right, so it goes like this. If you draw that, it's good enough. Something like that. I will give them that. And write sketch of g of x. Right. So it's a must show maximum point and the y-intercept. So the maximum point is here, which is a half minus 11/4 or minus 2 1/4, and the y-intercept right here is 0, -3, because on the function the -3 is a constant, right there. So that is the graph, the sketch. But got it that?
Yes, sir.
Yes, sir.
Alright, good. Let's continue. So this is a GP now. This one says in a GP, in a geometric progression, the third term is 25. The third term is 25. So the third term is 25. The third term is AR squared. Remember, the nth term of a GP is AR to the n minus 1. So the third term is AR squared. So AR squared, they tell us, is 25. And it says the sum of the first and the second term is 150. What does that mean? The sum of the first and the second term is 150. The first term is A, And the second term is AR, A times R. That sum is 150. He said determine the sum of the first 4 terms given that the R is greater than 0. So that's 2 equations that we have that we need to solve. Right? And I want the sum of the first 4 terms. Now look here, to get the sum of the first 4 terms, this is sum of the first 2 terms, you know. That's 1 and 2. This is the third term. So to get the sum of the first 4 terms, we just need to find the 4th term and add it to these. Alright? We just need to find the 4th term. And the 4th term would be AR cubed. Alright? But to do that, we need to calculate the R first. Alright? We need to work out what the R is. So to do that, we want to solve these 2 equations simultaneously. And I told you that simultaneous equations that are derived from a geometric progression are usually best solved by dividing them. When you get simultaneous equation from an AP and arithmetic progression, you add or subtract them. If we divide these 2 equations right now, we will be eliminating the A. So from these 2 equations, I'm going to divide. I'm going to divide them. I'm going to divide the second equation by the first one. I'm going to put the second equation on top. So I'm putting the top of this side, which is AR. Either way, I can put this on top of this, so it doesn't matter. Let's put this one on top of this one. So this left side, which is AR squared, over this left side, which is A plus AR, will be equal to this right side, which is 25, over this right side, which is 150. That's what you're solving. And then the A's cancel, right? The A's cancel. So this A cancel with this to give you a 1 and cancel with that A as well. The A's cancel, alright? So we're going to cancel the A, divide over here, so by the A, I cancel the A. That's right, cancel A. We'll cancel the A. We're going to get just R squared alone from this over, this becomes 1, maybe divided by a, and this becomes R equals, I know what is reduced to now. 25 into this goes 1 time. 25 into this goes what? 6 times? 6 times. 150 divided by 25. Isn't that 6? 150 divided by 25 equals 6, right? This becomes 1 over 6, right? So this becomes 1 over 6 when you simplify it down. This becomes 1 over 6. 1 over 6. Put it back in blue. And then we're solving this now, right? So we're going to cross multiply this over here, multiply that over there. We're going to get 6R squared equals 1 plus R. So take this and multiply it over here by the 1. I'm going to take this and multiply it up here by the R squared. So it becomes 6R squared. Bring this over this side now. Minus R minus 1 equals 0. So factorizing this now. So the let us space to work. We're going to get 3 and 2. 3 and 2 because midterm is a 1. So we're going to get 3R, 2R, 1 and 1. Signs are different, give the greater product of minus. The greater product is this far one, make it minus. This one plus. That equals 0. This factor gives me R equals a third. No, minus a third. This one gives me R equals half. R equals half. Alright. So this one is not valid because the R must be greater than 0, right? See here, the R is greater than 0. Let's see these things in question. So this one is not valid. Now you don't need to work out the A for this question, you know. Why? Because you know the third term. And the fourth term is simply The fourth term is simply the third term times r. Right? That's all that it is. Let me see if this factorize good. Bam, 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 bam. Let's see if this makes sense. Let's check it. Let's check in. Yeah, r equals a half. All right. Yeah, we can check it because we take the half now, for example, for the r and put it up here. So we'll see what the a is if you want it, but you don't absolutely have to work out the a. You could work out the a by putting this half in this equation right now and get the a, right? Or if you put it here, so it will be a plus half a equals 150, which is basically 2 over 2a equals 150, which made the a equals 100. I multiply by 2, you get 300 divided by 3 is 100. A equals 100, right? So you could work out the a if you want it, but I'm telling you, you don't need to. Or if you put the r in this one, half in this one, you get 8 times a half squared equals 25. Now half squared is a quarter, so I get a over 4 equals 25. Take the 4 multiply it up here, you're going to get a equals 100. Alright, so you can work out the a if you want, but you don't need it because I want us to find the sum of the first 4 terms, right? Sum of the first 4 terms. So see here now, sum the 4 terms. Since we have the terms, the sum, the 4 terms become the first term plus the second term, which we know these two is 150, plus the third term, which is ar squared, plus the fourth term, and the fourth term is just this term times r, right? Which is ar squared, whatever this is, times another r. So put in the values, the a plus ar is 150. We know that already. I'm showing you that they don't need to record the a. So these two add up to 150. Plus the third term is 25. See here, the third term is 25. So this will be 25. Plus the fourth term will be 25 times r, which is a half. Not a quarter, Mr. Shaw, half. And you work that out, you get the answer. I'm going to do the other way where I find the r and find the sum of the fourth term, just to show you. So this guy, that is it. This will be 1. Not that. Spread this over quickly with the calculator. So it's actually to be 175. So it should be 175 plus, it should be half of 25, or 25 times a half. Times half is 0.5. That's 187.5. That's the sum of the 4 terms. But okay with that?
Yes, sir.
I'm to do find the R, find the A as well. I'm not good with this. In this question, based on what I want, you don't need the A. And I was explaining to you. Don't need the A. But let's do it with the A in this like a box right here. And show you that, you know, if you decide to find the A, you could still get the same answer. Let's put it in this box. Let's put R beside it. So find the a, I could put in a half in this, right? So you have 8 times half squared equals 25. This is a quarter. You have to multiply both sides by 4 to get what the a is, so the a become 100. And if you're doing the sum to 4 terms now, sum to 4 terms, that will be a into 1 minus r to the 4th power, as the sum of the 4 terms, over 1 minus r. So it will be the a, which is 100, into 1 minus the r is a half, or 0.5, raised to the power of 4, divided by 1 minus the r again is a half, or 0.5. So let's put it in the calculator and see we get the same answer. Doing it another way, we'll find the a. Right? So it will be 100. Let's put the fraction first, and then 100 up here, and 100 up here, times 1 minus 0.5 to the power of 4 close bracket, and you put that over. But you all know that 1 minus 0.5 is 0.5. You get the same answer, 187.5. So we could have done it this way as well. We calculate it and use the sum to 4 terms formula. All right, that is that. That is. Then we'll come to this alpha beta question. Straight ADMATS question, this, right? It says alpha and beta are roots of this equation. Determine the value of this. So see, I tell you guys, at ADMATS these days, they don't ask anything more than that. That's the value of expressions. But you still have to work out what the alpha plus beta and the alpha beta is from this. So in that term, the A is equal to 2, the B is equal to -5, and the C is equal to 3. So the sum of these two roots, alpha plus beta, sorry, is minus B over A, as you know. So it's minus this B, which is -5, over the A, which is 2. Minus minus plus, this becomes 5 over 2, or 2.5. And then the alpha beta, product of the roots, is C over A. And the C is 3 over A, which is 2. 3 over 2 is 1.5. So we're trying to work out this value. So we can say now, 1 over alpha squared plus 1 over beta squared. We want to make it into one fraction. It becomes equal to, multiply this one by beta squared over beta squared. Multiply this one by alpha squared over alpha squared. So the two denominators become the same. So what happens here now is that the numerator becomes alpha squared plus beta squared. Alpha squared plus beta squared over the denominator becomes alpha squared beta squared, which is the same as alpha beta r squared. Alpha beta r squared. And then now, this alpha squared plus beta squared up here is actually now equal to alpha plus beta r squared minus 2 alpha beta. You divide that by alpha beta r squared. And you put in those values up here in this. So put in these values that we have. So the alpha plus beta is 2.5. This becomes 2.5 squared. Minus 2 times alpha beta. Alpha beta is 1.5. 2 times 1.5 divided by alpha beta again is 1.5. That's 1.5 squared. And you work that out with a calculator. Quick and fast. Working this out. So the fraction, that's 2.5 squared minus 2 times 1.5 divided by 1.5 squared. We'll get 1.44. Show that can express a fraction 13 over 9. So it becomes 13 over 9. Or you can put this one 149. Alright, that is it. That is it. Very good with that. Okay with that, guys.
Yes, sir.
All right, and then I think I gave you 3A. I think I gave it though on that maths paper. Let me see what I gave it to do. Yeah, 3A. So it was all of number 2, which we just did. So that's good. Full number 2 that we're able to do out of 6 questions. So remember, in your exam is 6 questions, and we're at the stage now we can do. I'm tackling 3 questions also, so not bad in terms of where we're at. Then we come to number 3, and it's just 3A we're supposed to do. Give it 3A alone. 3A only, I give it to do. Add maths. We can do 3B too. Can do 3B as well. Alright, I think I want to do 3B as well. It said determine whether the lines are parallel. Let's see if we can do 3C too. And what said 3? It says 3A and B I should have given you. Alright, this one says determine the equation. The equation of a circle. So this is the center and pass through the origin. So from the center, it passes through the origin, like the circle stay like so. 5, -2. 5, -2. So you have 5, -2 right here, so. And 5, -2, and like it passes through the origin here, so 2, 0, 0. And this point is 5, -2. So the distance between these two is the radius. Once you know the radius, you can get the equation. Remember now, the equation would be, so truth origin is 0, 0. The distance between these 2 points is the radius. So the equation is x minus a squared plus y minus b squared equals the radius squared. In this case, the a is 5 and the b is -2. So we need the radius, which is the distance between these 2 points, which is rather easy, because those 2 values are 0. So the radius is the square root of this minus 0 squared, which is same as 5 squared, and -2 minus 0 squared, which is same as -2 squared. The radius becomes the square root of 25 plus 4, which the radius is square root of 29, which means that the radius squared is 29. So 29 is coming right here for the radius squared. Alright, and in this, the a is equal to this value of 5, and the b is equal to this value of -2. And so this equation that we want, we can write it now. It's x minus a, which is 5, squared, plus y minus and -2 becomes y plus 2 squared equals the radius squared is 29. And this is the answer right here. That's it. Easy question. Very good.
Yes, sir.
Alright. Determine if the 2 lines are parallel. Parallel lines have the same gradient. So we just need to find an expression for the gradient for each of these. And to do that, we're going to write each of them in the form y equals mx plus c. Make y the subject. So for the first one, the y is equal to minus x plus 4. For the second one, to make y the subject, right? This one. Let's do it over here. We have 3x minus 2y equal -3. You can take this 2 over here and make it the subject, and take this 3 over here. So we would get 3x minus plus 3. When this 3 comes out, it becomes a plus 3 equals, then this 2y goes over, it becomes a plus 2y. Then if you divide through by this 2, so if you divide through by this 2, this becomes 3 over 2x plus this becomes 3 over 2 equals y. So that's now y equals mx plus c. So see now for this one, the gradient of line 1 is equal to -1. Coefficient of this is -1. And the gradient of line 2 over here is 3/2. Right? So we can say since m1 is not equal to m2, the lines are not parallel. They're not perpendicular either. Because if they were perpendicular, when you multiply this and this, you get -1. So basically the lines are not parallel because the gradient are the same. What good at that?
Yes, sir.
And the Almas paper done. That I gave it to do. Let's move over now to the other one, which is the pure maths paper. What I'm going to do, I'm going to do the add maths level questions first, and then we just finish off with the pure maths level questions. Alright, so this is the 2018 pure maths exam paper, and there's some add maths level work on it. Alright, so for that paper, I'm going to pick out the questions that I said the add maths students start to go first, and that starts with 1C. And then we'll come back and do like 1A and stuff for the pure maths, right? So here's 1C. That's add maths level work. It says given that this expression is equivalent to this expression, we are to calculate the value of A, B, and C. Alright, so this can be done multiple ways, but what I would do with this, I would take this, expand it out, and then compare with the coefficient of this. That's what I would do with this question. Expand it out, expand out this expression, and then I will compare that with this one. All right, I think that's a good enough approach. That's not the only way, but yeah, we could approach it that way. All right, I can know what the C is right away now, because I see the C is the product of these three values. Well, I know the exact C. I know the relationship between the A and the B, the B and the C. And then this last -10 is product of these three values. So it's the A I can know off the bat. So I can know the A right away. Right? What I understand, zoom up some more. Let's see what they're talking about. So if this thing and this thing is the same, this first value you know is the product of this, and that. You know that. Alright, so it's 2 times 1 times B is equal to C. So you know that 2B equals C right there, so. Alright, and then this times this times this. How about this one? Those three is equal to -10. So that's minus A equal -10. So right away you know that A equals 10 without doing anything. Alright, but let's go and so we're gonna expand out this and compare with this one, right? Can work out the 10. It don't make no sense we do it more difficult. We can work out the A first, you know, and get that out of the way, you know. So we know firstly that the A times the -1 times the +1 out here times the +1, that's all equal to this -10 out here. So that's -A equal -10. So the A equals 10. So you know the A is 10 to start. Alright, so this expression, because the A is 10, we can put it in, right? So we can say therefore 2x plus 10, because it becomes a 10, right, times x minus 1 times this, which is bx plus 1, is equivalent to all of this, which is cx cubed plus 10x squared minus 2x minus 10. We deal with the 10 already. We can establish a relationship now, as we said. This times this times this equals that. So we look at the coefficients. It will be 2 times 1 times b equals c. So that one relationship. So we can write that. 2, I'll put this up here. I will put no from up here. That 2 times 1 times b equals c. So 2b equals c. So we have this relationship. We're going to start expanding this now so we can compare it with that, right? So the 2b equals c. Alright. 2b equals c. So that is equal to 2b. But let's expand this now. Let's expand this out and then compare it over there. So firstly, we'll multiply these two first. So I multiply these two. Multiply these two. So we're going to keep back this one and multiply these two. It's going to be 2x plus 10 times, expand this now. Ready? It's going to be x times that is bx squared. And this times this is x. This minus 1 times this is minus bx. And minus 1 times 1 is minus 1. Alright, and then we're going to expand this part now. So we're going to take each of these and multiply this over here, so now, right? So using the 2x first. So it's a 2x times this is going to give us 2bx squared. And the 2x times this is going to give me plus 2x squared. Then the 2x times this is going to become minus 2bx squared. Then this times this is going to be minus 2x. I'm going to use a 10 now times each of these, the 10. So it's going to be the 10 times this is 10bx squared. Let's put on your 10bx squared. So I'm going to get 10bx squared. 10bx squared. And this time this is going to become 10x plus 10x. Then this times this going to become 10bx minus 10bx minus 10bx. Then this time this is negative 10. Let's consolidate all the values now, right? So what this is all one expression, and I will compare it with this, right? So I'm put this in a different color. So we're comparing it with this, everything up here. Let's put it in a different color. Let's put it in black. Alright. So I'm expanding this out. Expand this first to get this. And then I'm expanding this now to get everything that I have down here. Let's consolidate the values now. So, oh, this is supposed to be a cubed. It's supposed to be a cube, my mistake. Cubed. Alright. Let's consolidate now. So again, that's the only cube term. So it's 2bx cubed. The square terms now are all of these. Those are all the square terms. Alright. So look at the b part. This is minus 2b plus 10b. That's 8b. So it's 2 plus 8b. So you're going to get 2 plus 8b x squared. You know what that means? It means this equals 10. So that means, so the b equals 1. But if we're going further, that equals 10. But let's finish that and find the values another way, other way. So we're going to do the x term now. These are your x terms.
Stop short changing yourself.
Mute your mic, please. Mute your mic. So this now, in terms of the x terms, this and this is 8x minus 10b. So I get plus 8 minus 10b times x. That's what these give us. This is 8x, see? 8x factorize x and minus 10b. What it means now is that this term under here is equal to this negative 2. So again, you could find the b that way, which you're going to do and see if we get the same b. And then now we have this negative 10 equals this negative 10. So we're going to have minus 10. So if we compare coefficients now, and compare coefficients, we know that this equals the c, which we have up here, sorry, yeah? So I can write that again, 2b equals c. That's coefficient of the x cube, right? So x cube. The x cube term gives us 2b equals c. Then the x squared terms now, right here. X squared terms gives us 2 plus 8b equals 10. So from this is that the b equals 1, right? B equals 1. Because 8 times 1 is 8. 8 plus 2 is 10, so the b equals 1. If you use the x terms, which is this and the negative 2, we would be getting 8 minus 10b equals negative 2. Again, the b needs to be negative 1 because 8 minus 10 is negative 2. Right? So the b needs to be 1 again. So b equals 1. And then if the b equals 1, you take this and substitute it for the b, then the c equals 2. So you can write, therefore, the c equals 2 times 1, c equals 2. So the answers are, solution are, the a was equal to 10 from up here. The b is equal to 1 and the c is equal to 2. That is it. So they give 2 whole pages to do this, now, guys. 7 marks. 2 whole pages. That's 3 unknowns, but that is it. 2 whole pages they give to do it. But that is it. So the matter, in simple terms, the matter of expanding this and compare it with the coefficients on this. That's what it's about. Alright? Expanding and compare it with the coefficients. Alright? Yeah, that is it. Another way we could have said, alright, watch this now. Another thing we could have said now, we could have said x minus 1 is a factor of this. X minus 1 is a factor. So it means that f of 1 is equal to 0. So we're going to find the c straight off like that, you know. So we're going to do it another way. Find the c another way. Let's see. Do it another way. Let's do it another way up here. Maybe up here good enough to do it. That's a factor. X minus 1 is a factor. Then f of 1 equals 0. Right? So if we call this f of x, do the part in purple. But I've also said this x minus 1 is a factor. So x minus 1 is a factor. This is the easy way. So f of 1 equals 0. So now put 1 in here. This expression becomes 0. I could find a c. Just like that. So put 1 here, so you're going to get c. Put 1 here, so you're going to get 10. Put 1 here, so you're going to get minus 2. Put 1 here, so you're going to get 10. Minus 10. That's all equal to 0. So this 10 will put this 10, and this negative 2 goes over there. You get c equals 2. And after I get c equals 2, you know, so 2b equals c, right? Right, from this. So 2b equals c, same way. Because as I said, this times this must give you, must be equal. So you could have gone and say 2b equals c, and the c is 2, then the b must equal 1. So therefore the b equals 1. So actually I did the question a long way, This is the easiest way to do it. And then again now, this times this give you the a quick and fast. So this is the easy way to do it by recognizing that x minus 1 is a factor. So actually I did it a long way. I feel like to rub out all of this. It's too much work. I'm gonna rub it out. I'm not gonna leave it on there. I'm rubbing this out. The easy way to do it is recognize that x minus 1 is a factor. X minus 1 is a factor. It's right in front of us. Let's do the easy way. See there? X minus 1 is a factor. Right, so two things. This times this equals this, right? So setting that up first. So it's 2 times 1 times b equals the c. That's for the x cubed. That's how we get the x cubed, right? Which means that 2b equals c, right? And then this times this equals the 10 out here. So constant is that a times minus 1 times 1 equal negative 10. So it means that the a equals 10, right? And then the most important one, or the easy one, is recognize that's a factor. So x minus 1 is a factor. Therefore, f of 1 is equal to 0. So put 1 in this, it equals 0. So put 1 in here, you get c times 1 cubed plus 10 times 1 squared minus 2 times 1 minus 10. That's all equal to 0. So you're going to get c plus 10 minus 2 minus 10 equals 0. And so this cancels this, and then this negative 2 goes over there. So the c equals 2. And if the c equals 2, you can plug the c equals 2 right here. So we can say therefore 2b equals 2. Because the c is 2b. Alright, let's put it over here. So c equals 2b. And so the b equals 1. So the solution, quick and fast, is that a equals 10 right here, b equals 1 right here, and c equals 2 right here. Same answers. So I did a lengthy way a while ago. So never really have to expand this out. Use a factor theorem and get it quick and fast. And as I said, this question can be solved quick and fast like this. On an exam where they give 2 whole pages on a pure math exam. 2 whole pages with 7 marks down here. Because they don't know that they're providing for persons who won't do it this way quickly. And maybe the way that I just did, because that's the 2 ways that I've done it are not the only 2 ways. So I think this is the easiest one. I know this is the easiest. I don't think there's an easier way than this to do it. Recognizing that this is a factor. I use a factor theorem. Nice. But good? But okay?
Yes, sir.
Alright. Let's continue. I gave the advanced students 1C. I also gave you 1D. Even though this has a change of base law that is not under admaths, but it's just one additional thing. So I want to still use the laws of logs. So these two things have the same, 2 different base. I must do logs with the same base. Alright, so what we're going to do is a change of base law for this one and bring everything to base 2. Or the change of base law go? It's like this. Log of a number to a base equals, if you want to change the base, from the log of this number over the log of the b, and then you put in any new base you want on both of them, m, like that. I'm going to apply the change of base law to this one, and I want the new base to be 2, not 4. 2, because this one is already at base 2. So if applying that, this thing will become the log of this thing, which is 2x plus 2, over the log of 4, and I'm putting in the new base to be 2. Put it on in purple. Log to base 2, log to base 2. Then I go now to put back this minus log to base 2 of x plus 1, and that's all equal to 1. Now log to base 2 of 4 is actually equal to 2. Put it over here, so why that is so. Alright, put these things in some boxes that we're using. So we use this first. This is actually 2, because this is the log to base 2 of 4 is same as the log to base 2 of 2 squared. Then these 2 can come to the front and becomes 2 times the log to base 2 of 2. And log to base 2 of 2 is 1. So it becomes 2 times 1, which is equal to 2. That is it. So this is on there says equal to 2. Alright, hold on a second. Hello? Yes? No, I'm in a class. About what? You know, so I can't find, I was looking for it this morning, but I'll check. When I don't, I'll check. I saw it, I was looking at December 22 and I didn't see it. So I think we'll have to search, but I think should have sent it. Should have sent it before that as well. So search. Alright. I saw December 22. Alright, cool. Alright guys, sorry about that. So this becomes a 2. And to divide by 2 is to multiply by a half. So this whole thing can become this, look. This whole thing becomes half log to base 2 of 2x plus 2 minus log to base 2 of x plus 1 equals 1. Alright, now this half can come up here as a power, or we can multiply through by 2. Your choice, whichever we want to do. Right, we can multiply through by 2 to get rid of the half, or we can bring this half up here as a power. I think I'm going to multiply through by 2 more rather than create a half. So multiply through by 2. Alright, when I multiply through by 2, it becomes, and I recognize that this is a factor of this, because this is 2 times x plus 1, Right, so I'm looking at to see, if something is going. Usually with logs and trigonometry questions, there are always multiple ways to do the question, right? So don't mind if you see me pausing, like I'm just looking if there may be an easier way to do the question. There's always multiple ways to do these questions, not one way. Always multiple ways to do the logs questions and tricks questions, because there are so many laws and identities that we can apply. But I'm going to multiply 2 by 2 instead. So I'm going to multiply this by 2, I'm going to multiply this by 2. So I'm going to get log to base 2 of 2x plus 2 minus 2 times log to base 2 of x plus 1 equal, multiply this by 2 and I get 2. Then this 2 now bring it up here as a power, right? So I get log to base 2 of 2x plus 2. Maybe I should factorize the x plus 1 minus log to base 2 of x plus 1 squared equals 2 out here. So Let me write this as 2 times x plus 1. This thing instead. 2 times x plus 1. The laws of logs say when you subtract logs, you can divide. So I'm going to do the log of this divided by that. So I'm going to do the log to base 2 of 2 times x plus 1 divided by x plus 1 squared. That's all equal to 2. What does this mean? It means that I brought it down to one of the format that we want and put it in a box here for you. When you have a log of a number to a base equals a power, it means that this number is equal to this base raised to this power. And that's what we essentially have now, right here. It means that this whole thing is equal to 2 raised to the power 2. If you want to go from log to indices. But what is this thing? This thing can be simplified. This thing right here can be simplified because I can cancel x plus 1 here with one of them out of this. So it becomes 2 over x plus 1. So all of this becomes 2 over x plus 1. If I write another line for you, we can do it like this. Log to base 2 of 2 over x plus 1 is equal to 2. So this number is equal to 2 raised to the power 2. So 2 over x plus 1 is equal to 2 raised to the power 2. That's this base raised to this power 2, which is a 4. That's a 4. That's a 4. I can multiply this up and divide on the 4. So we're going to get x plus 1 over here equals 2 over 4, which is a half. That's a half. And if this is a half, I subtract a half, I get x equals half minus 1, which is minus half. So x equals minus half. That's the answer there. X equals minus half. I'm getting, unless, because that's a negative number, especially I want to check if that answer is valid. Would it work in the original equation? So if you put a minus half here for this x, you'll be calculating log of a half. And you put minus half here, you'll have 2 minus 1. So it will work. So we can accept this half answer right here as our answer. It's not going to cause us to be finding log of a negative number. So maybe I did it more steps than needed, but that's all right. That's all right. That is it. X equals minus half is the answer. Are you okay with that?
Yes, sir.
Yeah. We could have instead we could have done it another way and instead change this to log to base 4 now. Could have done it as well and write this as log of x plus 1 to base 4 over log of 2 to base 4. Could have done it as well like that, right? So we have changed everything to base 4 instead of to base 2. Right? Could have done that as well. Alright, but that's a good enough solution right there. Next question. We're not doing this because that's functions. We don't do this yet. Pure maths, we'll have to do this, but don't do it yet. This is pure maths again. This again is pure maths, modulus functions. This is pure maths. Let's see which other question I'll say most to add maths student and pure maths people. Let me see. So I gave you 1C, 1D. On the pure maths paper, 1C, 1D. Let's make sure. This was 1D, yes, 1C, 1D. Then 2A. I'm saying advanced students go to 2A. It's a mistake. No, I don't want to do 2. It's a mistake. Let's see. Not this. I put 2A for this. I don't want you to do. That's a mistake, guys. Yeah, it's a mistake. Yeah, I don't want to do 2A. I have 2A for that math student, which is wrong. So it's 4A. Let me say 4A. 4a. Yes, this one advanced students can do. Alright, yeah. So I put 2a. Yeah, 2a is not for advanced, right? That's a mistake. Yeah, that's a mistake. We can do this one though. So sorry if you actually tried 2a. Not ready for it to the 2a as yet. Alright, the question said the equation of a circle and a straight line are these. So that's a circle, that's a straight line. It said determine the center and radius of a circle. So I'm going to complete the square and get it in the form x minus a squared plus y minus b squared equals the radius squared. Now this is not the only way to find the center and radius, guys. Don't get me wrong, but this is the way I prefer to do it, because a lot of the times you go on to use the information we have from this, especially the center point. So let me complete the square of these two, and of these two. So taking this equation, I'm going to put these two together first and get x squared minus 2x, and then y squared plus 2y, and this plus 1 equals 0. Complete the square of these two. Now we get x, and half of the negative 2 is negative 1 squared, and then subtract the square of this, which is 1 squared, plus these two. Now it becomes y, and half of this plus 2 is plus 1 squared, and then subtract the square of this 1 squared, and then adding back this 1 equals 0. So this becomes x minus 1 squared and y plus 1 squared this is minus 1, and minus 1 give me negative 2. Negative 2 plus 1 is negative 1, and that goes over on the other side to become equal to 1, which is same as 1 squared. So the center and the radius. The center is, if you compare this and this, see that the A is 1 and the B going to be minus 1. I can say the minus B is plus 1, so the B is negative 1. So the center is AB, which is 1, negative 1, and the radius R is equal to 1. R is equal to 1. That's the equation of that circle right there. Alright, and those the center and your radius. Next part now says show that negative 1, 2 is one point of intersection of the C and the straight line. Now, to show that this is a point of intersection, we do have to solve them simultaneously. Now, we can show that this point satisfies both of them. Show that that point satisfies both of them. So the circle, I can use this formula for the circle, is x squared minus 1 squared plus y plus 1 squared equals 1 squared. I can test this point in there. So test 1, negative 2 in this, and see if it equals 1 squared, right? Which is 1. So it will be 1 squared minus 1 squared plus negative 2. This y is negative 2 plus 1 squared. And this works out, this is 0. And this works out to be negative 1 squared, which is 1. Right? So it is true. This is now equal to 1. So that is true. This 1 squared is 1, And then we want to test it on the line now. The line is, what was the line again? Y equals x minus 3. Y equals x minus 3. I'm going to test 1, -2 on that line. If it's on the line and also on the curve, then it's a point of intersection. So the y is -2, see the y is -2, and that becomes equal to the x value, which is 1 minus 3, and this also is true. Therefore, 1, -2 is on C and L, and so it's a point of intersection. But I understand that I didn't have to solve it.
Yes, sir.
Not to solve it. I can just show that the point is on both of them. That's one way to do it. I don't have to solve it. So it don't give you so much space, you know. It just says show. And show that is one point of intersection with the line. And that's it. I don't have to do all of that, but I say. Show that the point satisfies the two equations, and that's good enough. If you want to solve them, you could go ahead and solve them. Alright, and then show that that point is one of the solutions. Alright, so let me show you if we were to solve them and show the point. So if we were to solve them simultaneously, it would be the circle. Let me copy down the circle. This is a circle. Copy this down. Here. If we were to solve them simultaneously, and the line is y equals x minus 3. You're solving them simultaneously, right? So you're going to take this and substitute it here and here for the x answer, right? So at intersection, the y here, here, and y here are all the same. So you can replace this for the y at intersection. So you're going to get x squared minus 2x. This y squared becomes this squared plus x minus 3 squared plus 2 times this y again is x minus 3 plus 1 equals 0. I'm solving this as x squared minus 2x. Expand this one now. We got x squared minus 6x plus 9. We expand this, that's what I get. And you expand this, you get 2x minus 6 plus 1 equals 0. So these are your square terms, two of them, 2x squared. And the x terms are this, and that. That give you a negative 6x, right? Because these two wipe out each other. You're left with this, negative 6x minus 6x. Then the constant now is this and these. That's 10 minus 4. 10 minus 6 is 4. This and this is 10 minus 6 is 4. So get a plus 4 equals 0. You can divide the 2 by 2. Get x squared minus 3x plus 2 equals 0. You factorize this, you get x and 1 and 2. Signs are the same, they are both negative. Minus minus equals 0. So you're getting x equals 1, x equals 2. And at x equals 1, I put it in a curve, y equals, in the line, y equals x minus 3. I'm subbing this. So subbing that, you're going to get y equals 1 minus 3, y equals minus 2. So it means that 1 negative 2 is 1 point. 1 point of intersection. So you could have done it that way. But I think the easy way to do it is just put them in the line and the curve and see that it satisfies both of them. And the other point, if they wanted it, would be right here, x equals 2. Again, I go sub in y equals x minus 3. And to be y equals 2 minus 3, y equals negative 1. So the other point would be 2 minus 1 should be the other point if they wanted it. But I think I did it the easy way first, right? So let's show you that as well. More maths equals better maths. Oh, this one said determine the equation of a tangent to the circle at this point. Alright, determine the tangent at that point. No. This circle passed through the point. What was it again? The center point was what again? 1, negative 1, right? Center point is 1, negative 1. So a circle. Center point is 1, negative 1. You have this point down here is 1, negative 2. Note have the same x value as that. Is 1, negative 2. So right below it. Be mindful of that. The x value is the same. So it means that your normal is this. It's your normal, you know, a vertical line. That line passed through 2 points where the x value is 1. So this line is x equals 1. That's your normal. So your tangent is this horizontal line. That line is a horizontal line passing through negative 2. So it's y equals negative 2. That's it. Now that you know the calculation. Tangent is y equals negative 2. That don't need no calculation. Okay, passing the center and the point of tangents have the same x value. And so the normal is a vertical line, x equals 1. So the tangent perpendicular to it, so the tangent must be horizontal and pass through this point where the y value is negative 2. Horizontal line will always have an equation y equals the y value at any point that it passes through, which is negative 2. So that is it. This don't need no calculation. If you try to calculate it, you're going to get infinity for your gradient of your normal. If you try to calculate the gradient of the normal between these 2 points, you're going to get infinity. Because the run is going to be 0. From 1 to 1, the run is 0. And if your gradient is infinity, it means that you have a vertical line. So if normal is vertical, then your horizontal, your tangent is horizontal. But question like this don't need no work. Just observation. 4 marks for just doing that. Easy. I would give them the sketch, exam paper, and leave it at that. This don't need any work. I will give them this sketch for sure. And write it down. Tangent is that. See that? Very good.
Yes, sir.
In pure maths, they like to set these vertical and horizontal line questions. Where if you calculate the gradient, for example, you get an infinity. So if you try to find the gradient of the normal right now, you're gonna get the difference between this and this is 1. So you're going to get like 1 over 0, which is infinity for the normal, gradient of the normal. So the normal is gradient is infinity, then the tangent gradient is 0. The tangent gradient is 0 means that you have a horizontal line passing through this point. So if you proceed, work with a gradient of 0, then you'll be doing y equals mx plus c, and the m is 0. So it will be y equals c, right? And the c at that point is this. Negative 2, so it will y equal negative 2. So if you even try to work it out, don't be afraid when you get infinity for your gradient. All it means is that you have a vertical line. The vertical lines have a gradient of infinity, infinite gradient, because there's no run. I think I'm done with the add maths. Yeah, I'm done with the add maths. I'm just going to go back now and do questions for pure maths. So, add maths students, you can stick around. So Luke, you can stick around. What's in here? We're doing AdMaths. Nobody else in here doing AdMaths. Luke, is he alone in here for AdMaths? Nobody else is pure maths that I'm seeing. Yeah. Alright, let's go. So what are the pure maths questions now? First one here. This one says, let P and Q be any two proposition. Complete the truth table below. All right. So the start is first right here. So the negation of this column first. So not true is false. Not true is false. Not false is true. Not false is true. So the negation of this column. So not true is false. Not false is true. Not true is false. Not false is true. So we're doing P or Q. That's between these two. Remember, R is true, any one of them true. Alright, so for this one, we're doing these two, right? These two. We're doing the R for these two right now. So true or true is true. True or false is true. False or true is true. False or false is false. That's it. Then over here, we're doing the negation of this column. So when you negate true, you get false. When you negate true, you get false. When you negate true, you get false. When you negate false, you get true. Then we're doing not P and not Q. So we're doing the and between these two now. We're doing the and between those two. That's what this is, right? Now, and is true only when both of them true. So false and false is false. False and true is false. True and false is false. And true is true. That's it. Right off the bat, I can see that these two are the same. So they are logically equivalent before they even ask me. Because they have the same values. And you should know that if you expand this, or if you distribute this not over this junction, you're going to get this with the conjunction, because the negation of a conjunction, this junction is a conjunction. Or the negation of not is and. Alright, so these two are logically equivalent. It's a hence state whether this one, which is this column, and this one, which is this column, are logically equivalent. Sorry. And give a reason. The reason that the truth values are the same. Right? The answer is yes. They are logically equivalent. Alright. Yes. The truth, that's because this is the reason, right? Yes, they are logically equivalent. Why? Because the truth values are identical. They have identical truth values. As you can see, they are the same. That's what this is. They are the same. Next one, a binary operation. It says a binary operation style define an array set of numbers R, and real numbers R, such that A star B is equal to this. Alright, A and B are in R, meaning that A and B are in a set of real numbers. Calculate 5 star 2. So we put in the 5 here for the A and the 2 here for the B. Alright, simple as that. That becomes equal to 2 times 5 plus 3 times 2. That becomes 10 plus 6. That becomes 16. Nice and easy, right? Next part says, prove that R is closed in anything. This one state right. It is a set that is closed. The set that is closed. Remember, it is A star B equals, what is it now? It is 2A plus 2A plus 3B. If you look at this operation closely, it comprises of multiplication. That's what this is. That's a multiplication. And over here is a multiplication as well. And this is an addition. So operation star comprises of addition and multiplication of real numbers. Now, addition of real numbers and multiplication of real numbers are operations on which the set of real numbers is closed. In other words, any two real number you multiply or any two real number you add, you're getting back a real number. So the set of real numbers is closed with respect to addition and with respect to multiplication. So since this operation star comprise of two operations on which the set of real numbers is closed, it means that when you combine them, the resulting operation is going to be such that the set of real numbers is also closed on that operation. All right, and that is the logic behind it. So I'm going to write it out like this as a statement that I always write. When it's a prove that the set is closed, just going to say something like this. They said this, they call it this, I call it star, right? If you want to write about the same thing that they gave you, no problem. E, whatever this thing is, B. Let's call it star, because, let's call it star. Right? I'm calling it star. So I'm going to say, all right. Operation let's write it. Circle with a plus. Alright, separate this device. Comprises of addition which is the plus and multiplication which is a multiply, talking about this and that multiplication. If you want to specify it, you can say that's a 2a and the 2b and the 3b we're talking about. Those are multiplications. So it comprise of the addition, that's the plus right here, and the multiplication, which is 2a and the 2b, they are multiplications, right? Of real numbers. So operation, whatever this is called, comprises of addition and multiplication of real numbers. This set R, which is a set of real numbers, the set R is closed on addition and on multiplication. Therefore, it, that's the set, it is also closed on operation. Whatever that operation is called, that's it. As a logical statement. This operation star comprises of addition and multiplication of real numbers. And the set of real numbers is closed with respect to addition and multiplication. Then the set of real numbers must also be closed on this operation, because the operation comprises of other simpler operations, that's the addition and the multiplication, on which the set of real numbers is closed. And that's all we need for this statement. We don't need to do any mathematics to prove it. That is it. Are we good with that? I have to learn this statement because I like to ask this question. I like to ask how to learn to write this statement. Right there. Alright. It said determine if it is commutative. It's not going to be commutative. Because commutative, when you reverse the order, the result must be the same. So remember, what we have so far is A star B equals 2A plus 3B. And we already worked out that what did we work out? Work out 2 star 5, or was it 5 star 2 is 16. So what I'll do is reverse this and see what we get. So 5 star 2 is 16. And we also have 5 star 2 is equal to 16. We have this already. So I say now, what is 2 star 5? What is 2 star 5? It will be 2 times 2, 2 times the first value, plus 3 times the second value. This should be 15 and 4 is 19. That's 2 star 5. Therefore, you can say that 5 star 2 is not equal to 2 star 5. One is 16 and one is 19. And therefore, star, you see, I'm calling this thing star, right? Don't worry about it. Is not commutative. Because if it is not commutative for one case, one single case, then it's not commutative. Alright? Not commutative. And that is it. Very good. But after that, Miss Jan Free, you alright with that? Miss Malaika, Miss Tavia, Mr. Nekanjo, Miss Tiana. What's happening? I'm not hearing from any of you. Body mic muted. What happened? Jan, you sleeping? Malaika, you sleeping?
No, sir.
So why not answering me then? So I can't bother them class here. Alright, this one now. So prove that this thing is equal to that. Now this is an application of the something on the syllabus that I don't say very often. We'll call it again the triangle identity. Let me show you it's set up. I'm gonna apply it. Alright, that's something that you must know. So it's like you have this. We're gonna apply this to it. Triangle identity. So we're gonna call this vector here A. Call this vector down here so B. And if this is vector A and this is vector B, then this resultant is A plus B. What it is that the length of this must be less than or equal to the length of this plus the length of that. Makes sense, right? So the modulus of A plus B has to be less than or equal to, can't be greater than, has to be less than or equal. Because if this point come down to here, so then it become equal, right? So less than or equal to the length of this side, which is the modulus of A, plus the length of this side, which is the modulus of B. That's what we're applying. That's what we're going to apply. Now to use this and prove this up here, we're going to be smart about the application now. We're going to let this part equal to A and this part equal to B. So I'm going to say, okay, let the A be equal to this part, which is the x minus z, and the B be equal to this part, which is z minus y. Then what is the A plus B? I'm going to add these two now. So I'm going to say, therefore, the A plus B is equal to, I'm adding up this now. If I add up that, then this minus z and this z cancel each other. You end up with this left, x minus y. And if you use these on this now, these substitutions on this, then the A plus B, I can put in here so, and put it as x minus y. The modulus of x minus y is less than or equal to the a, which is this one up here, x minus z, plus, that's this plus, modulus of b, which is modulus of z minus y. Shown. Done. Soft with a capital T. That is it. So you have to know this. That's what you have to know. I can draw that diagram and use it as a reference to prove this up here. Are you good?
Yes, sir.
I'm gonna write for A and B, which are real. So we define this as A and that as B. Then they are also real. I'm already defined A and B as real, so these must be real as well. The Z and X must be real. So I'm gonna write it down here. So for all X, Y, Z that are real numbers. That is it. Nice quick proof done. What's marks for that? 4 marks. Quick and easy. You have to know this, guys. You have to know this thing, right? That is it. Alright. That is that. Down here now is for us to solve this modulus thing. Now we have modulus on this side that less than, right? And we're going to use the identity result. What are the identity results that you all must know in modulus? Let me write them out here for you that you must know. So the first one is that the modulus of A is the modulus of A equals B, or the modulus of A equals the modulus of B. Then you solve A equals plus or minus B, and you test your answers. Test answers to eliminate the one that won't work. That's one. If you have the modulus of A is less than B, then you solve A less than B greater than minus B. Solve that. These are like standard results. If you have the modulus of A greater than B, then you solve A less than minus B, or A greater than B. So in this case, you're between the minus A and the B up here. So down here, so you're outside the minus A and B. So this one is equivalent to having a smile graph. Put it in blue for you. Having a smile graph, and you want under here, right? And this is the A, right? And this point is your B, and this is your minus B right here. And down here is equivalent again to having again a smile graph where your axis is A, this is your B, this is your minus B, but this time you want up here. So you're going to the right of this one and to the left of that one. And then now, third form result is if you have the modulus of A greater than the modulus of B, then you solve A squared greater than B squared, no shortcut. And if you have the modulus of A less than the modulus of B, then you solve you square both sides, expand and solve. So you solve A squared less than B squared. Those are your form results that you must know for modulus functions. So This one can become that. That's a less than sign. Works for less than or equal to. All of these work for less than or equal to, right? Whether less than or less than or equal to. But this one is like that. But what we need to do is transpose this x over here first. Right? So we have the modulus alone on one side. So this one relates to this up here, and we leave an R on it. That's the one it relates to right now. Alright. So first I'm going to make it relate to that perfect. I'm going to bring this over here. So when I end up with the modulus of 6x minus 2 less than or equal to 5 minus x squared. Alright, that's what we're gonna get. So we're solving this now. So this in here is like a A, this out here is like a B. Alright, so I mean that this in here is A, which is the 6x minus 2 comes less than or equal to the B itself, which is the 5 minus x squared, or greater than or equal to the negative of this, see? Minus B, and put it as minus 5 minus x squared. Because you have x on all the sides and squared and stuff, you can't transpose and leave x alone in the middle. So what you're gonna have to do, you're gonna have to work out this part up here so by itself, and work out this part down here so by itself. That's what you're gonna have to do. Alright, so this becomes two separate inequalities. So I'm gonna put this part and this part separately. So I'm gonna put a line down here now. I'll work them out separately. Put a line down here. So you're working out this part first and put in the negative values. I'm gonna get minus 5 plus x squared less than or equal to 6x minus 2. That's this half of it. And then this half of it, this other side of it is going to be 6x minus 2 less than or equal to 5 minus x squared. And you solve the two sides and so you get. And then when you finish now, you try to see what the common region is. Alright, so let's do this one first. So leave the x squared over here. I always work with the x squared positive. So I'm going to keep this as x squared. This 6x comes over this side, will become minus 6x. And then this negative 5 is over here. This 2 comes over, come a positive 2. This 2, positive 2. 2 minus 5 is negative 3, less than or equal to 0. And that can factorize, right? So we're going to have to use the quadratic form. This is like a smile with the x-axis here, and you have two root values here and here. And you want the part under here. The question is, what are these two critical root values? Yeah, those two critical root values, can put this equal 0 and solve it. Alright? I'm going to do that over there, so to get those two critical root values I want to go between. Alright, to get here and here, put them on in red. The value here and the value here. We're going to solve this, put this equal 0 and solve it. So x squared minus 6x minus 3 equals 0. Going into quadratic formula. So it will be x equal minus a negative 66 plus or minus the square root of b squared, which is 6 squared, minus 4 times a is 1 over here, so times c is negative 3 everything over 2a is 1. So x equals 6 plus or minus square, what is work out to know? That's 36 plus this is 12, which is 48. I guess we have 48 on here. And dividing that by 2. Alright, so you get the 2x value. Let me get the calculator and work them out. Alright, x equals, alright, let me work them out over here. The calculator. It's the wrong thing, you know. Alright, the calculator. Working out this. As it becomes a fraction, 6 plus square root of 48 over 2. So I'm getting 6.46. Or the minus, let's change this to a minus. I'm getting negative, I'm right the positive one over here, 6.46. 6.46. I'm going to write 6.5. And down here, so I'm getting negative 0.5. Let's keep that negative 0.5, negative 0.5. So those are the two values. So this is negative 0.5, that is that, right? So this is 6.5 and negative 0.5. So on this side, the solution will be between those two. So the solution right now, which is a part of the solution, is that the x will be less than or equal to 6.5 greater than or equal to negative 0.5. That's what this part, this half of the thing is giving me. I might need to do the other half now over here. Let's do this part now. Alright, so again I'm going to take this x, bring it over here. I'm going to get a positive x squared. This 6 is over here already, so I'm going to put plus 6x. And then this 5 comes over, and I get negative 7 less than or equal to 0. So again, I'm going between two values. Again, this can factorize. This can factorize. Yes, this can factorize. 7 and 1. So let's factorize this one. This one can be factorized. Is x and 7 and 1. Signs are different. Give the greater product the plus. So let's make this plus, make this minus. So it's a smile again. And this factor is giving me 1. This factor is giving me negative 7. And again, I'm below 0, so I'm between them again. So this time I'm between negative 1 and negative 7 and 1. So it's x less than 1 greater than or equal to negative 7. Alright. So now I have those two answers. I can't just accept everything. Alright? I can't just accept everything. It's like I have to find what is the region, what is the values, what are the values that satisfy everything, right? So chances are it might be on this end and on this end. Let's see. So we want test values. So we want a value, for example, that is less than 6.5, but greater than 1, because we want to see if 1 is where we have to really stop, right? So we're going to test a value like 2. So we can test 2. Let me make this smaller. I need a calculator for the test. I need a calculator. Test a value like 2. See if 2 works on the original equation, right? So I'm gonna test 2. So as I said, no, this one goes all the way up to 6, but this one stops at 1. So I want to see if we actually need to go up to 6. So I want a value that is less than 6.5. I can test another value that is greater than 1. If a value greater than 1 don't work, right? Then we know say yes, so we have to stop. We can't go past 1. So let's test this end of it first, right? So we're gonna test. Let me do the test in black for you. So we're gonna test x equals 2. We're testing it on the original up here. Original thing up there, right? So if we test 2, it's gonna get 6 times 2 minus 2 modulus of that plus 2 squared. We want to see if it's less than or equal to 5, if that is true. Now 6 times 2 is 12. 12 minus 2 is 10. The modulus of 10 is 10. This is 10 plus 4. Less than or equal to 5, not true. No. So you know, say you can't go up or 2. You can't go past this. So it means that this result is not valid. So you have to stop up. You have to go below 1. Alright? So this end is, in terms of the upper end, you can't use this one. You can't go past 1, because this is telling you they have to be below 1, because 2 don't work. And 2 is a value less than 6.5 but greater than 1. Right? So it means you can't go past 1. You get me? 2 doesn't work. And then now you want to see which down at this end now. Do I go all the way down to -7, or do I stop at -0.5? So I can try value at -2. Because -2 will be more to the left than -0.5, right? But you don't quite reach -7. So if -2 works, then it means that it's okay to go all the way out to -7. If we can try like -6. But let's test like -2 or -3. Let's test -2. Let's test x equals -2. In the case, -2 gone past this. Alright? So let's see. -2 gone past that. And it's going to be within the -7. So let's test -2. So it will be the modulus of 6 times -2 minus 2 plus, and then say this now is x squared. That will be -2 squared. Need some more space. Let me shift this over a little bit. Shift this over a little bit. And zoom in. Right. So now plus -2 squared. I want to see if that is less than or equal to 5. What is this in here now? This is -12 and -2. That's modulus of -14. The modulus of -14 is 14. Plus, it becomes 4. Is that less than or equal to 5? No. So it means that I cannot go past this -0.5. I can't go past it. So it means that my solution has to stop here and stop here. I can't go down to here, so, and I can't go up to this. So. Right? So my solution, which is my answer, I'm going to put my answer then, is that the x have to stop at 1 and -0.5. Can't go outside of those two. That's it. That's my solution. That was a nice question. I like it a lot. Like this one. But I wrote that. Very good. Miss Jan, you good?
Yes, sir.
Alright. Another thing you could have do, you could have draw the region and see where these two inequalities overlap. Where the two of them overlap. Alright, so if you put them on and put in where they overlap. You put on this one, you go like this. 0, 1, minus 1, minus 2, minus 3. And we'll just put on some values on it. So let's put on some values. Hold on. Let's put on those values. Keep it simple. So 0, 1, 6.5, -0.5, -0.5, and -7. All right. So one range. This range is here, -7 to 1. That's one range right there. Purple. I'm going to put another range in blue. The other range is from -0.5 all the way up to 6. That's the next range. If those two ranges overlap, is right inside here. Is the region that satisfies both sides of the inequality that we solve. And that's why that is your solution. X less than or equal to 1, greater than or equal to -0.5. But I like the method of testing values. That's the overlap region for the two solutions. Alright, so this blue was for this, and the purple down here is for that. The red is where the two ranges overlap, satisfies both sides of the inequality. This side of the inequality and that side of the inequality satisfied inside a red region. Alright, and that's why that is a solution. Right? You see, the thing is, when you write this, when you write this, right, you're ready to solve when you divide it half and half. You want a solution, you want a solution that satisfies both. You want a region that satisfies both. Right, and that's right inside here. So we'll have a look at it that way as well, rather than testing values. Alright, enough of that. Let's move to the next one, which is this. I think this is the last question that we're doing. I gave it to the number 4C. So much page I give it to do it. 2C, let me say. 2C. I know the 4A already here. 2C. This is the last one we're doing for today, guys. Alright. So this one gives us this equation, and it has these three roots. So determine equation with these three roots. That's all we need to do. So we need a new equation with these three roots. And they tell us just that this is equal to this expression, and this is equal to this expression. Now, if this equation has these three roots, we can get the sum product and the sum pairwise product and product of these three roots from this equation first, before forming the new equation. So from this equation, right, that's what the A and the B, there's no C on it. So the A is equal to 2, the B is equal to -1, and the x squared is there. There's no C, there's no x term there, so the C is equal to 0, and the D is equal to that constant value there. The D is equal to 1. So the alpha plus beta plus gamma from this equation is minus B over A. The B is -1, so that's minus 1 over 2. Then the pairwise product, alpha beta plus alpha lambda plus beta lambda is C over A, but the C is equal to 0, so this is just equal to 0. And then the alpha beta lambda is minus D over A, and the D is 1, so D is also 1. Alright, so make a mistake here. It's minus D over A, so minus D. So it becomes minus 1 over 2 as well. Alright, now because we have these, we can actually work out these values right where they are now. Alright, so this one can work out from now and put what it is right here. So it becomes the pairwise product squared, and the pairwise product is 0, so that's 0 squared, minus 2 times the product of the three roots, which is this, minus half, times the sum of the three roots, which is another minus half. Let's put what that is equal to right there. So this becomes minus 2 times a quarter. Because it's minus becomes a plus. That becomes minus half. Like we said, this time this gives you a 1, right? So let me take it, that's minus half. So this works out to be minus half. Minus 1 over 2. So this thing is minus 1 over 2. Then we can record this one as well, right where it is, here. This one. Work it out right now. That's the sum of the roots squared, and the sum is minus a half. So it's minus a half squared. And minus 2 times the pairwise product. Minus 2 times the pairwise product is 0. 0. So that becomes a quarter, because this is 0. This just becomes minus half square, which is a quarter. So you know those two things already. Write them out right there. Alright, I already formed the new equations now. New equation now. So, new equation. With roots. One over alpha squared, 1 over beta squared, 1 over lambda squared is x cubed minus the sum of these three roots times x squared plus the pairwise product of these three roots times x minus the product of these three roots. That's equal to 0. That's an equation. So we need to record the sum of these three roots, the pairwise product of these three roots, and the product of these three roots. And no doubt these values will help along the way. Alright, let's go. So I need the s first. Alright, so the s that we want right here is the sum of these three things. So it becomes 1 over alpha squared plus 1 over beta squared plus 1 over gamma squared. You put this as one single fraction. You multiply this one by beta squared gamma squared over beta squared gamma squared. Alright, so it becomes pairwise product squared. Alright, so this one we're gonna have beta gamma squared plus, and this one multiplied by alpha squared gamma squared. So you're gonna get alpha gamma squared, and then this one gonna multiply by alpha beta squared. Alpha squared beta squared, so you're gonna get alpha beta squared all over, and then these three becomes the denominator, which is alpha beta gamma all squared, if write as a single fraction, which then becomes equal to, now all of this up here is this that they gave us. Let me say that work out to be minus a half, and this under here is just this pairwise product right here, minus a half as well. So it becomes minus a half on the numerator over minus a half squared, which becomes 1 over minus a half, which is negative 2. That's what it becomes, minus 2. Minus 2. Because it becomes minus half over a quarter. It becomes a quarter. To divide by this first, to multiply by 4. So we have minus a half times 4, which is minus 2. Good. That's minus 2. So s is minus 2. So minus 2 is coming right here for this s. Then we need now the pairwise product of these three things. Alright, so we're talking about P2, which becomes, multiply these two first, you're going to get 1 over alpha beta all squared plus multiply this and this, you're going to get 1 over alpha gamma all squared plus multiply these two now, you're going to get 1 over beta gamma all squared. Then to make this into one fraction, you multiply this numerator and denominator by gamma squared. Multiply this one numerator and denominator by beta squared, and multiply this one numerator and denominator by alpha squared. So it becomes equal to gamma squared plus beta squared plus alpha squared over alpha beta gamma all squared, which is, now alpha squared, beta squared, gamma squared is right here. That works out to be a quarter. That's a quarter over, and this now is the product of the three roots squared. Product of 3 is minus a half squared. That's minus a half squared. It's a quarter. So a quarter over a quarter is 1. So P2 is 1. So P2 coming right here, so is 1. We now need the product of these three roots. Alright, so P3 down here becomes 1 over alpha, beta, gamma, r squared. If you multiply these three things, that's what they're gonna get. Which becomes 1 over minus half squared. Remember, the product of the three, which is minus half. This becomes 1 over a quarter. 1 over a quarter is 4. So P3 is 4. Alright, so those are the values. We're dropping them in this equation now. So the equation becomes, is x cubed minus s, and s is the negative 2. So it's minus s. A minus a negative 2 becomes plus 2. So you get plus 2x squared plus p2x. See it here? Plus p2x. P2 is 1. That's 1x. So you're going to add 1x. 1x is just x. And then minus p3. And p3 is 4. P3 is 4 down here. So we're going to subtract 4. That equals 0. And that is your answer. That's the equation. Nice and easy. I did all in red, but that's alright. What good at that?
Yes, sir.
That is it for the day. That's it for today, guys. I think we're going to have the trigonometry next. Trigonometry is our next topic. Yeah, trigonometry is our next topic. And we also have vectors to do. I think we're doing vectors in the Tuesday, Friday class, trigonometry in the Sunday class. But then we're going to also have this 3D vectors to do on Sunday. I send a message in the group tomorrow what to do in Sunday, guys. By tomorrow, I send a message in the group what we're doing tomorrow, what to do in Sunday. If you're actually going to have a pre-math class on Sunday, I don't want to be doing anything new online. So, if you can't do it face-to-face, if your person is still overseas and can't come to the face-to-face, then we put it off. I mean, it's just one group, so we can always adjust, make sure we capture everything in time, right? So, I'll take a little feeler from a class who can come to face-to-face class on Sunday if we were to have it, and let you know and make a conclusion by then. Alright, but I don't want to be teaching anything new online. Anything we're doing online must just be revision. Alright, guys. So see you all soon. Bye.
Okay, sir.
I'm gonna send the video for these. Rewrite the questions if needed. Alright. Bye, everybody.